So let's see some interesting problems in linked list. Yes, first question, detect a cycle in single linked list. So given a single linked list like this, where there is no end node here, but there exists a cycle in the linked list, how do you detect a cycle in the single linked list? Generally, in linked list, we have a single linked list. When we talk about, we have two things. One is the this is the pointer part, this is the data part. We can have this way, we connect it to the another node, right? So the node structure, it has two parts. One is data part, the other is the address part, which is used for connecting to the other node, right? So I have a single linked list like this, and there is a cycle. How do we detect a cycle? Let's say I have some numbers here, 10, 20, 30, or 4, 5, 6, 7, 8. So this is the list what I have with me. Now we have to detect whether there is a cycle or not. So generally, how do we traverse a single linked list? Traversing, we generally, if there is no loops, let's say there is one list like this, definitely in the single linked list, the last element will be, the address of the last element will be null, and we have only one pointer here. This is my head. Okay, so what we do, we will write one, we will take one temporary node, let this be temp, and we will have it while temp next not equal to null. So is this temp next not equal to null? No, no, null, no. So we will be traversing the list until we reach here. Okay, or we can even write this condition while temp not equal to null. Okay, so we will be traversing, and if you want to print, if you want to count the number of nodes, that we can do it here. But in this problem which you are seeing here, there is no end loop. There is no end loop here. So how do we detect a cycle, whether there is a cycle in the single linked list or not? So to solve this problem, the approach what we see here is, actually we will try to apply. There are so many techniques to do that, but the most common technique here is using pointers. So we use one common technique, that is using forward and backward pointers. So so what we have to do here, we have to create two temporary pointers. Okay, so I think you are aware of this small game of tortoise and rabbit. They will be running on a race, right? Rabbit as well as tortoise. So ultimately we know that tortoise wins because rabbit stops at some point, right? So in the same thing, what happens there, one in a circle, if you see in a circle, rabbit is running in continuous fashion. Okay, tortoise also moving. There is a chance that definitely both rabbit and tortoise will meet at some point. By the time tortoise completes one round, rabbit might have 1.5 round or 2 rounds completed, right? So there will be definitely one common point where both the rabbit and tortoise will meet, right? So in spite from this technique, we have one approach using two pointers. One is fast pointer, the other is slow pointer, So we call this as two pointer approach. So how you try to do here using fast and slow pointer? See, you rabbit is your fast pointer and tortoise is your slow pointer, right? So rabbit will jump 2 steps, whereas tortoise can jump only 1 step. That is the logic. So let's see how it functions here in solving this problem. So initially both the pointers will be here, FP and SP, fast pointer and slow pointer. Okay, so after in every iteration, fast pointer will move 2 steps, whereas slow pointer will move 1 step only. Okay, so what will happen? My the next will be, here comes my slow pointer and here comes my fast pointer, because it will take slow pointer will take 1 step, whereas fast will take 2 steps. From here what will happen? From 3 it is going to, where will be my next fast pointer? Next fast pointer, which is at 3, will be at 5, because it will leave 4 and it will come here. So here is my fast pointer, and here is my slow pointer. Next, this iteration is over. In the next iteration again, fast pointer will move from 5 to 7. So here my fast pointer will come and my slow pointer will move only one step ahead. Fast pointer will move 2 steps, slow pointer will move 1 steps. So because of this, slow pointer comes here. Next, what is the next step? Where will fast pointer will come? From 7 it will jump 2 steps. So it will skip 8, it will come here. So here is my fast pointer and here is our slow pointer. Okay. Next, after coming here, what is the next step? Fast will jump 2 steps, slow pointer will jump 1 step. So because of that, this fast pointer will come to this point and slow pointer will move 1 point. Slow pointer, not fast, slow pointer. Next step, what is the next logic? Fast will move 2 steps. So from 5 it will come back to 7. So FP will come here and slow pointer will move 1 step. So it is coming here. See, if both the pointers, slow pointer and fast pointer, meet at single point, if both the pointers data is equal, then we say yes, there is a cycle, because they are meeting in a circle, they are meeting at some point. It means they are roaming in the same path. So this is the approach for finding out whether there is a path or a cycle in a single linked list or not. Okay. So again I will repeat the solution. It is very simple. We use 2 pointer approach. We use fast pointer and slow pointer. Right. So what does this fast pointer do? Fast pointer will jump 2 steps at a time, whereas slow pointer will jump 1 step at a time. So in that process, if both fast pointer and slow pointer are meeting at some point, if they both are meeting at some point, then we say there is a cycle. Okay. So this is the problem and this is the approach of solving this. Coding, how will you write? Again, creating linked list node part that I am skipping for now. Actual code, if you see, finding out whether there is a cycle or not, if you write some function detect cycle, if you write here and node star temp. Okay. So if you we can give it here head, we are passing the head value, right. So what is the logic here? So you are taking a pointer, right. So FP, so FP equal to while I will write that condition, I will come back to this condition. See what you will do here, FP equal to FP next. So you will move it 2 times and slow pointer will move only 1 point, slow pointer equal to slow pointer next. Okay, this will happen. Now what is my condition? If SP data is equal to fast pointer data, like we have seen here. See, FP data is 7 and SP data is also 7, both are data is same. When if slow pointers data, current slow pointers data and current fast pointers data is same, then you will simply write cout cycle detected, or maybe if you are using any whatever language you are using, we will say cycle detected and we will exit, we will break it, we will break that loop. So break or exit, you can do it here, right. How long should I keep repeating this? How long can I do this? Generally we have to do this in a looping condition, right. So that condition we have to decide here. So again, how long should I repeat this process? At some point definitely it will break, right. So here we have to give the condition FP not equal to SP, right. Pointer, the FP pointer and FE pointer, both the pointers until they are not equal to, right. Some point they will be equal to, so that time it will break and it will keep checking this, right. So this is the logic for detecting the cycle in a single linked list. Okay, very interesting problem. This is the most important point here, 2 pointer approach, we have to use this, and based on this 2 pointer approach only we can solve the problem. Let us see the another set of questions. Let us go for second problem. Yeah, again we call this as Floyd cycle finding algorithm. We call this technique of in cycle finding out whether there is a cycle, detecting a cycle or not, whether the two pointers are meeting or not. We call it as Floyd cycle finding algorithm using two pointer approach. Okay, it uses two pointers moving at different speeds of walk to walk the linked list. Once they enter the loop, they are expected to meet, which denotes that there is a loop. Okay. So, this is one important classical problem. Again, the idea behind discussing this problem is to understand the two pointer approach, because there are so many problems based on this approach. There are so many problems based on this approach, right. So, let us see the next problem. Yes, find the middle element of the linked list. One more classical problem, which is also similar to that problem what we have seen previously. Find the middle of the linked list. So, you have a single linked list with you. There will be three 1, 2, 3, 4, 5 and 6. Let there be 6 elements, okay, or 5 elements. You have to find out the middle element. So, how do we find out the middle element of the whole, because these are all simple list, but in exams or in questions they will give questions as you have some 100 linked list or 150 linked list, find out the middle element. How do you find the middle element in a linked list? Okay. So, how do we solve this problem? Again, let us see the solution for this problem. Find middle of the linked list. So, you can draw it like this also. Here we have null. Let us take this example only what we are seeing here. So, by this we can simply say that 3 is middle, because by seeing, but how do the compiler understands, right. So, here also same approach of using two pointers. Here also we use two pointers approach. Okay. So, again how do we do this? Same, we use slow pointer and fast pointer. Here also we use slow pointer and fast pointer. So, let us take two pointers here, let it be FP and let it be slow pointer, fast and slow. Same approach. What is the logic here? SP will move one step, SP is next, slow pointer is equal to slow next, fast pointer equal to fast pointer next. Okay. So, FP will move 2 steps, SP will move. How long should I do this? How long should I do this? When FP of next becomes null, until FP of next becomes null, keep doing this process. So, once this while loop breaks, wherever the current SP is pointing to, that will be our middle element. Now, let us apply it here and see what is the logic. See, both FP and SP here. First iteration, what will happen? Slow pointer will come here, fast pointer will come here, because it will jump 2 steps. So, this is my SP, this is my FP, fast pointer. Next, after second iteration, FP will jump to 5. So, this will be my fast pointer and my SP will come here, slow pointer will come here, slow pointer. Okay. Next, you see, now FP next is null, it became null. FP does not have anything after this, it has reached the end. So, whatever is the current position of the slow pointer, that is the middle element. So, you will you have to write SP equal to SP next, FP equal to next. This will repeat. Once the while loop is done, outside this while loop, simply write, you can write printf, whatever you want to write, printf %d comma slow pointer data, that is 3. Okay. So, same logic, the reason to discuss these two problems, because they follow same approach of using pointers, slow and fast pointers, middle element. I hope you understood the approach. Logic is very simple. What we do, in case of odd number of nodes, this is 5, okay. Slow pointer will reach the middle element while fast pointer will reach the last node. Okay, so see what is the point here. I am saying here, if suppose there are odd number of elements 4, 5 and 6, then there is null. So my FP will be here, fast will be here, slow also will be here. After first iteration, slow comes here and fast comes here. This is our first iteration. After this, fast will come here and slow will come here. Now see, fast next is not null, so it will try to go next which is null. Here we don't have anything, fast is not pointing to anywhere, right? So it will point to this, but generally slow has to come here. But after 6, do we have any element? After 6 we don't have any element here. So when my fast was here, that's it, if we reach the end. So my slow was here at the 3, right? Slow was here at 3. Okay, now see the point. See, slow pointer will reach the middle node when fast pointer will reach the last node, and in case of even number of nodes, right, this is normal, fine. Linked list, slow pointer will reach the middle node when fast pointer will become null. Okay, so in this case fast will become null and this will become your slow. So the middle element will be given as 4 in this case. Okay, because see 3 or 4 both is there, but since our condition what we are writing here, we wrote one while condition, while fast next not equal to null. This was our condition. So in case of even number, what happened? This was my fast and this was my slow earlier, right? So 5 next, is it null? No, it is not null. So it will try to go 5 next, that is fast next will come to null. That will happen, and slow will come to this 4, right? So that's the case here. In case of odd number, it will directly give the value, whereas in even number nodes, slow pointer will reach the middle node when fast pointer will become null. Okay, so it has to jump from 6, it has to go beyond, then this will become the middle element. That is the logic. So in both the problems, the idea is to use pointers, slow and fast pointers approach. Okay, so these are two problems. Let's see the third one and the interesting problem. I hope you are understanding the problems. We are just seeing the approach of how do we solve the problems. Linked list, the reason for starting linked list is this is one of the most important interview based topic for asking in interview. They use linked list. They give a problem and ask you to tell what is the solution, what is the logic for that. Whereas tree problems, including binary search tree, all kinds of tree, max heap, min heap, everything is most important for coding type of questions. It doesn't mean linked lists are not asked in coding rounds, but this is a general understanding that linked list questions are asked in interviews, in face-to-face discussions more, whereas tree based questions are asked most in the coding. Okay, so I hope these two problems are clear. Let's go for the third problem. So find nth node from the end of a linked list. So if there is a linked list 2, 3, 4, 5, 6, okay, let's say till here. I want the second last node. Okay, third node from the end, second last node I need. So in this case 1, 2, 3, 4. See, third last node from is 4, 3, 2. 2 is the answer. In this case, second last node will be 5. So how do you find out the nth node from the end of the linked list? Okay, so the input here is the list as well as the n. So how do we solve this problem? Right. So again, see, all these series of questions are following same approach, that is pointers, using additional temporary pointers to solve the problem. Okay, so let's say I have a list 2, 3, 4, 5, 6, 7. Let's say this is my list and I gave n equal to some 3. I want the third node from the end. So, our answer should be 5. 5 should be our answer. So, how do we solve this? What is the solution for this problem, right? So, same approach again, what we try to do here, we try to see, the logic is simple. The total length is 7, and the number given is 3 for me. So, difference is 4. So, I have to traverse 4 times. Wherever I stop, that will be my element, that will be my third element from the end, right. So, for that, how do we do? Do I have to find our length first and subtract and then traverse it? One solution what you can think is, first you will find out the length of the list. You will write while loop, while temp not equal to null. You can write temp equal to temp next. So, and you will write count plus. So, you will come to know the count, that is 7, and you need the third last node from the end. So, that n you know, that length you know, you came to know length, let us say L plus. Length of the linked list you came to know, and the number n which is given in the input you know. After this, again you will subtract it and you know the value is 4. So, you have to do 4 times traversal. You have to do 4 times traversal. Wherever temp stops, that will be your answer. So, here in this case 2 while loops are there, right. In this case we are getting, so this is one solution for this, finding out length of the whole list, and then subtracting that length of the whole list, that n given 3 from the whole list. So, difference is 4. You have to traverse 4 times. You have to traverse it 4 times, right. So, once you traverse it 4 times, you come to know. So, first traversal, this is not null. So, you will move here, this is not null, second time, third time, fourth time. Once you traverse here, you reach to that point. So, this is the third most element from the end, right. So, this is one solution for this problem, finding out the length of the whole list by traversing the while loop and then subtracting the total length of the list which you found out and the given n. So, you get a count. Now, you can write some normal for loop also, for I0, I less than 4, I plus, temp equal to temp next. Once the loop ends, wherever is the temp, that temp value you print it. That is the third most element from the end. Okay. So, this is one solution for this problem. However, this is another solution also with same time complexity. There is another equivalent solution for this problem. So, solution 1 says find first solution is find the length, then subtract L minus n, then iterate let us say L minus n times, okay, temp equal to temp next. Wherever this loop ends, the current temp value is your nth node from the end. Another solution, if you see, solution 2 for this problem, how to do? I want to know, suppose I say, I again write a list. This is my list and given n value is 3, for example. So, I want the third third node from the end of the link, third last element from the end of the list. So, this is my answer, 5 is my answer. I have to find out. Again, you can take what you can do, you can take one pointer, fast pointer, or let us say P1, P2, let us not say fast and slow pointer, let us say P1, pointer P1 and P2. Okay. What is the n given? 3, right? Move the pointer P1 3 times. P1 is currently here and P2 is also currently here. With single iteration, move the pointer P1 to third 3 times. So, it will come here, move to the third time, right? Move it here. So, this is my P2, this is my P1. I made 3 moves. I made here 3 moves. Now, what you have to do? Simply move them until while P1 next not equal to null. Until this condition, keep moving forward, both P1 equal to P1 next, P2 equal to P2 next. We are just moving them one step forward. So, what will happen? So, P2 will come here and P1 will come here. after one iteration, right. Next again repeat the same process. So P2 is here, P1 is here. Next P1 will come here, P2 will come here. Next P1 will come here, P2 will come here. Next P1 will come here, P2 will come here. See, P1 has reached the end. Where is your P2? At 5. Okay, I will repeat the solution once again. Solution 2, you have a list like this, only 6 elements. You want to know the third last element, okay, or you want to know the fourth last element, let us say fourth last element. Okay, so move the pointer P1 4 steps forward. So P1 is generally here and P2 is again you can say fast and slow pointer. Move the fast pointer 4 steps ahead. So P1 will come here, P2 will be here. Just move this 4 times. Given n, you don't calculate the length, you don't calculate and subtract, don't do that. Okay, single iteration, move P1 pointer n value, n times means 4 times. So P1 will come here, P2 will be here only. Now until P1 becomes null, until P1 reaches the last node, keep moving them forward. So in this problem, fourth node from the end means answer should be 3. So what will happen? One iteration, P2 will come here, P1 will come here. Next second iteration, P2 will come here, P1 will come here. That's it. P1 has reached the end, P2 will stop here itself. So your while loop will stop. Where did P2 stop? P2 stopped at 3. So simply print P2's data is the fourth node from the end of the linked list. Okay, so any solution you can follow, time complexity is same for those. Solution 1, find out the length of the whole list and then subtract the n value from that and iterate it 3 times, or else do this thing. What you can do, given n value, move fast pointer 3 times, stop it there. Then from there until the fast pointer next is null, keep moving both P1 and P2 one step ahead. P2 equal P2 next, P1 equal P1 next. So this will keep moving forward. At whenever P1 next becomes null, P2 the process will stop, while loop will stop. P2 will end at some point. That point itself is the nth node from the end of the linked list. So though I don't say fast and slow pointer, but we are using 2 pointers here. Okay, so all these problems are in a single line, right? They are all in the same approach, following 2 pointers to find out the solution for the problems. Okay, so let us move to the next problem. See, basic understanding about linked list, I believe you all have studied these problems already. So I am just quickly going through. If you see the previous questions from different sources, internet, all those things, you will come to know. Anyhow, we have those problems in our sessions. Next, yeah, interesting question, very popular linked list question. Intersection point. If you read the interview experiences, if you have a habit of reading this, if you don't have, please start doing this. Use GFG to read interview experiences. Reading that boosts you, it gives you more confidence. They share the actual questions asked to you. You can feel if the same questions were asked to you, what will happen? Will you be in a position to answer it or not? It is a very good practice of reading previous interview experiences from the GFG or any other internet source. Okay, that is one good thing which you can do it here, right? So can you think of the solution for this problem? Intersection point of a linked list. Let me explain the question here. See, there are again there are 2 separate linked lists, L1, L2. Both are meeting at a single node, and from there they are ending it here. There are 2 separate linked lists, L1, L2. Both of them are having some common point here. They are having some common point here. From there it is reaching the end. So we have to find out the common meeting point of both the list L1, L2. We have to find out the common meeting point of both the list L1, L2. So how do we find out the intersection point of these two lists. So, this will have separate head 1 and this will have separate beginning head 2. This is what is given to us. We have to find out the common point. So, just think of this, how you can find out the common point. Let us see the solution for this problem. See, we are given two separate linked list L1, L2, right. So, what we have to do, little tricky problem. You have two separate headers here, H1 here is and this is H2. First thing, you find out the length of the first list, okay, you using that normal logic, while by taking a temporary pointer, while temp next not equal to null, null, simply do t equal to t next and L1 plus plus. So, this loop will give you the length of the first node. So, let us say 1, 2, 3, 4. So, we come to know length of list L1 is 4. Same way you do it for L2, you come to know L2 equal to 5. Now, after finding out the length of both the list L1, L2, now you have to find out the difference. So, again difference D equal to L1 minus absolute ABS of L1 minus L2 if you do. Why ABS function here? We do not want the negative difference, 4 minus 5 or 5 minus 4, it should tell me 1 as the answer. So, for that reason L1 minus L2, this value will be, difference will be 1. Now, you find out if L1 is greater than L2, again that the length whichever is greater, right. If L1 is greater than L2, then you have to move it one step, whichever is great, it has to iterate one step forward, it has to iterate d number of times forward. In this case, which one is the greatest? L2 is greatest, right. L2 is large. So, this will fail anyhow, I will tell about this logic. Else case what will happen? You have to move L2 node from H2 here, how many times? D times. You have to move your header, you have to move your starting pointer D times, that is one time. So, what will happen because of that? My the current head pointer will be here, the H2 will be shifted to this location. We will take multiple examples to understand, right. Now, you see H1 is here, H2 here. Now, compare, if again we will not move headers here, we will be moving temporary, actually we will be using temp pointers T, though H2 is here and H1 is here, we will be using temporary pointer. If T1 data is equal to T2 data, or until T1 data is equal to T2 data, or until T1 and T2 both reach null, okay, until both reach null, right. So, again T1 data, T2 data, are they same? No. Then move forward, T1 equal T1 next. So, T1 comes here, T2 comes here. Now, compare this data and this data. Is T1 data and T2 data same? No. Move forward. So, T1 comes here, T2 comes here. Is T1 data and T2 data same? Yes. If this is matching, then we say this is the element here will be the common intersection point in the linked list. Okay. So, this is one interesting problem what we have, intersection of both the nodes, right. So, how do we write the logic? First, you have to find out the lengths of both the nodes. You have to find out the lengths of both the nodes. So, what I will do here, first we will define this variable difference D and we will take count L1 equal to 0, L2 equal to 0 initially. I have to write two simple for loops, while temp 1, that is linked list 1, temp 1 next is not equal to null, temp 1 next not equal to null, simply you have to just increase L1 plus plus and T equal to T next, T equal to T next. Okay. Same way you write another while loop for the second condition, right. So, what you have to do here, same way you have to do it for L2, same I will just modify here, while T2 next not equal to null, same L2 plus plus and T equal to T next. This way you have the count of L1 and L2, After this, find out the difference. Difference equal to absolute of L1 minus L2. So, you have the difference. Now, whichever is greater, if L1 is greater than L2, then what you have to do? While you have to move that one node d times. So, one time. So, I will write here while d minus minus T1 equal to or head 1 equal to head next. Since L1 is greater here, head 1 equal to head 1 next. If L1 was greater, else what I have to do? Again while d minus minus, d could be any number, right? D could be any number. D minus minus and H2 equal to H2 next. So, this way we made both the head 1, either we moved the head 1 or we have moved the head 2 forward, right. Now, what is the simple thing? While both temp 1 and temp 2 not equal to null, simply check if T1 data is equal to T2 data, then simply break. Why breaking? Because that T1 data itself is the answer. You can print that. Else what I have to do? If this is not the case, what I have to do? You keep moving. T1 equal to T1 next, T2 equal to T2 next. This way you have to keep forwarding. Let us take another example to understand this interesting problem. This is very, very important. Intersection point in a given linked list. Let us say I have list L1, I will just simply write numbers 1, 2, 3, 4 and then we have a common point 5 and then 6 and then 7. Here I have some 6 or not 6, let us say I have 8, 9 and then a common point. Okay. This is my two separate list. So, this is L1 and this is L2. Generally we will find the count first. So, L1 value will be 7 and L2 value will be 1, 2, 3, 4, 5. So, this is 5. After this what I have to do? Find out the difference. Difference is 2. Then whichever is large. So, if L1 is greater than L2 the count, then what I am writing here? While what I have to do? See, if L1 is large, you have to move the header pointer of L1 2 steps. You have to move it forward. So, while d minus minus. So, while 2 minus minus, 2 is not 0. So, head 1 is equal to head 1 next. So, from here head will move here and then it will come here. So, this is my head 1 and this will be my head 2. Now, if condition, are they both null? No. Are 3 equal to 8? No. Move it here. H1 comes here, H2 comes here. Both are they null? No. What is the value? 4 and 9. Are they equal? No. Move forward. H1 comes here and H2 comes here. Are they both null? No. So, what is H1 data? 5. H2 data 5. Are they equal? Yes. Break that while loop and you can print either H1 data or H2 data and say simply say that the common point or the intersection point is 5 for both the list. Okay. So, this is one very important problem in the linked list, intersection point in a linked list. So, all these are very classical problems. Before intersection point, if they are equal, see again the data is expected to be different. Okay. See, we are trying to find out one data is all the elements are unique elements, that is the scenario here. So, there is no chance that 6, this is the list and there is no chance that there will be let me take some 5, some 4, 5, let us say 4 itself, 4, sorry 3, 4 and then this is the common point, this is the common point. So, we are not expecting elements to be same like this. Both the lists are two, scenario itself is both the lists are having different data items. That case it will this will hold. Okay. So, nice. Then yeah, very again, even in arrays, in linked list, in stacks, in queues, any data structure, very popularly asked question, remove duplicate elements. Okay, removing duplicate elements from, you should solve these problems today. Remove duplicate elements from an array, remove duplicate elements from a stack, from queue, from linked list, right? You try this. So today's question, the problem number 5 is remove duplicates from a sorted linked list. Okay, so I have a linked list here. You see, this is my original list OL 11 11 11 21 43 43 60. But I want to remove these duplicates which are in red color and make a list like this. So how do we delete the duplicate elements from a sorted linked list? Okay, very popular and powerful question, deleting the duplicate elements from the list. So how do we solve this? How can we solve this? Can you make a guess of how do we delete duplicate elements? Right? It's simple. Again, you are using pointers here. Once you practice the problems, you will be in the same sequence of understanding. You will compare this data with this. If this is same, right, what you will do, you will skip this connection and you will bring the connection to here. Then again you will compare this with this. If both are same, again you will delete this connection and you will shift the connection to this. If 11 and 21 both are same, no. When they are not same, you will shift your pointer to this location. Your temporary pointer will come here. Now again 21 with 43 are they same? Move your temporary. 43 43 are they same? Then skip this, jump to this thing. Let this be your T. Then you will reach the end. That's it. So you have broken these two connections and this connection, you get this list. Okay, it seems simple, but it is little interesting to solve this. How do we do this? So what is the logic? How do we write the program for removing duplicates from a sorted linked list? Right. So again, this is, I will write in simple terms. Let me take some simple numbers like this: 1 1 1, then 2 3 and 3 and then 4 and then I have null. Okay, so this is my head pointer. I have taken a temporary pointer T. Okay, so my logic here is while T next not equal to null, the very popular iteration logic. Until T reaches end, I have to do this process. What I have to do here, right? See, if T data is equal to T next data. See, T is here and this is here. This is my T data, this is my T next data. If both are same, your T is here, right? Make it T next. Make it T. Your T will become T equal to T next. So because of this, what will happen? This connection is gone now. This connection is formed. Okay. Again, same process. While T data is equal to T next data, right? So T is 1, T next data is 1. Then in that case, you make this connection and you bring this as connection. Okay. Now again, while T data is equal to T next data, no, else case, what you will write? You will simply write T equal to T next. You will write T equal to T next. So because of this, my T will come here. Because of this T will go and T will come here. From here, same procedure again. Is T next null? No. Is T data, that is 2, is equal to T next data? No. Then T equal T next. So my T comes to 3. Okay. Now from 3, if is 3 data is equal to 3 next data? Yes. So make your T equal to T next. So this will be my T. Now T has reached null. So this connection also gone. We reach here. So we get 1, 2, 3 and 4. I will explain this with another simple example here. Let's take let's say the same numbers here: 11 11 11 21 43. Yeah, 11 11 11 21 43 43 60, and here we have null, right? So this is my temporary. Again, this is our head, but we always take a temporary node. Okay, so this is my temp. I am checking here if this temporary, its next data, are they both same? if they are both same, don't jump. If t data is equal to t next data, yes, t data is 11 is equal to t next data is also 11. In that case, make your t as this. Make your t as this. Right. So we have to no, we are not moving this. We have to break this connection and update the t next. Update the t next equal to t next next. In this case, what I am doing here, this connection is gone. I am framing this connection. I am framing this connection. So this is gone now. Again go back to the while loop. Is t next not equal to null? Yes, not null. Then t data, that is 11, is equal to t next data, that is 11. Are they both same? Yes. In that case, its next should be 21. So this is also gone now. This link is gone. This link is created. It is updated. Again repeat. Is t next not equal to null? Yes, it is true, it is not null. So we have to check this condition. If t data, that is 11, is equal to 21, no. That's why we have else case t equal to t next. In this case, I am making my t as this. Now from here, this is my t. From here, repeat the same procedure. If t data 21 is equal to 43, no, make this as t. Is t data 43 is equal to t next data 43? Yes. In that case, break this connection, form connection with this. Now compare. 43 is equal to 60? No. Then make this as t. This connection is gone. Yes. T next not equal to null? It has failed because we have reached the null. That's it. Come out of the loop. So elements become 11, 21, 43, 60. Right. So this is also one very important classical problem in linked list, right. So my point here is to say that you should be able to know on paper give a solution for problem. There are I believe there are almost very limited but very classical. There are almost 40 plus classical problems in linked list for which solution is almost same. You have seen, right, how we have seen the different see, for this problem detecting a cycle I am using 2 pointers. For middle of the linked list I am using 2 pointers, and for this nth node I am also using 2 pointers here. So 2 pointer approach is a common pattern in these questions, right. So that way we are trying to solve the problem. So on paper you should be able to explain the problem, you should be able to give the solution for the problem. That is very important, right. So these are 5 important questions on linked list, previous company questions. So I have some one assignment question for you. See, delete nth node from the end of a linked list in a single scan. Amazon 2024 question, delete nth node from the end of the list. So we have seen one problem. What is the question? Find the nth node from the end of the list. That we have found out. What was our approach? Using 2 pointers again, P1, P2. We have seen 2 solutions for this problem. Using that approach, you find out that element. Then you have to delete that. Okay. So the reason for discussing these 5 questions was, you see here, delete the nth node from the end of a linked list in a single scan. Okay. So finding out the nth node first, that you have to find out. Then its previous and its next you have to map it. Okay. So you try this one problem. Then you see here, Flipkart 2024 question, given a single linked list, delete middle of the linked list. Okay. So these are actual questions. You can check in internet. You can read the interview experiences. You simply type Amazon 2024 linked list questions. You will find these questions. Flipkart 2024 linked list questions. You will find these questions. Right. So the base problems are here. We have seen how do you find out the middle element, how do you find out the nth element. Using these 2 concepts, you can solve these problems, right. Delete the nth node and delete the middle element of the linked list. So same approach you have to use, 2 pointer approach only you have to use. A slight modification you do, you can delete those elements, right. So previous 2024 asked questions, you please give a try to write only the core logic of these 2 problems. Okay. Right.